Hello, welcome back to our video series about polar equations. Today we're going to convert polar equations into rectangular equations. So taking our equations with probably a trig function, an r and theta, and turning them into an x and a y. Now there are a few things that you want to make sure you're aware of. Okay, all of these concepts we talked about when we were converting points in our previous video. So x squared plus y squared equals r squared. Might come in handy at some point. And then the two big ones, x equals r times the cosine of theta, and y equals r times the sine of theta. Those are probably going to be your most popular ones, these three. Because most polar equations have at least one of these three things in them. Then also keep in mind that, when you're drawing your polar equation and you have your theta and there's your r, you also have a tangent ratio, and that's your y over your x. And then I'm going to throw this out here because it might pop up at some point or it might come in handy. You know that your sine squared plus your cosine squared always equals 1, that Pythagorean identity from way back in the day. So, let's do a couple and just see what happens. So this first one says convert r equals 2 secant theta into a rectangular equation. So whenever it says that, that means get rid of any trig, get rid of any r's or thetas, and you want only x and y. That's the goal. So there is no direct trig ratio with secant. It's all sines and cosines. So that's a clue that you should probably change secant into its equivalent reciprocal, which, in case you forgot, secant is 1 over cosine. Cosecant is 1 over sine. So 2 over the cosine of theta. Remember, the 2 stays in the top of the fraction. So then I am going to, because I don't like fractions, I'm just going to multiply both sides by the cosine of theta. And actually something helpful happens when I do that. Notice r cosine of theta, r cosine of theta. R cosine of theta is x. So this equation is just x equals 2. Let's look at another one. Maybe one that's slightly more complicated. And I'm going to maybe show you 2 different ways to do it. So let me go ahead and I'm going to write down my two big rules. X equals r cosine theta. And then x squared plus y squared equals r squared. There's a couple different ways to do this. I'm going to show you 2 strategies just because they're kind of interchangeable. So first, this one, the previous one, because it was a secant, I ended up with a fraction that I could multiply to get rid of it. If I tried to divide by sign right now, that wouldn't really help me because there's no x or y that deal with division. So let's think about this in a different way. Since it's a sine, I'm going to be dealing with this. Y, it's going to have a y in it, r sine of theta. Since the r and the sine are not being multiplied by each other, you could manipulate the equation a little bit so that you can replace just the sine. So if you divide both sides by r, let's say, y over r equals the sine of theta. So then you can say, which is almost a little counterintuitive because you still have r's and you want to get rid of r's, but if you have r equals 6 times y over r, because that's what sine of theta is, then r equals 6 times y over r, you can multiply both sides by r. And then you have r squared equals 6y. Now, you still have an r, so you're not finished. But notice r squared is x squared plus y squared. So now you have all x's and y's. And then from here, you need to remember your conics. It should be kind of a clue to you that this is a circle because you have an x squared and a y squared and they have the same leading coefficient. So you want to go ahead, you can stop right here. Sometimes the directions will tell you to put it into your standard form. And so for a conic, that means you need to complete the square. I'll go ahead and practice that just because it's been a little bit since we've done it. So you have x squared plus y squared. You have to get everything on the same side. So then you're going to complete the square. And remember, I always do my plus and my minus the same number, which in this case is going to be 9 because I cut 6 in half. And I get 3. And I'm kind of out of space. I'm going to pop up here real fast. So this is x squared plus y minus 3 minus 9 equals 0. So my standard form would be this. Now, again, it all depends on what the directions say. If it just says convert into a rectangular equation, you can stop here. If it says convert to a rectangular equation and express it in standard form, then you have to go all the way and do this. All right, so that's one way to do this problem. I did want to show you another way that might be slightly more efficient. Some people like it. So if we start with our original, and you're looking at this, you currently don't have any of these perfectly. So what you can do, and what's always an option, if you wanted, is you can multiply both sides of the equation by r. So you get r squared equals 6r sine theta. Then you get the r sine theta. So you can swap it out with a y. And then you have r squared. Well, r squared we know is x squared plus y squared. You can do it both ways. A lot of times I like this way because then I don't have fractions. So this process doesn't seem as complicated. So we'll probably use that on the next problem. Convert r equals 2 sine theta plus 4 cosine theta into a rectangular equation. Again, I'll go ahead and write these down. So, looking here, I have r, I have a sine, and I have a cosine. But there's nothing connecting any, like there's no r and sine together, there's no r and cosine together. So I'm going to go ahead and use the second strategy that I used on the previous problem. And I'm going to multiply everything by r. So this would be equivalent to saying r squared equals 2r sine theta plus 4r cosine theta. Again, I multiplied everything by r. In doing that, now every single term has an r, and I have an r squared, so I can replace everything in one step. R squared is x plus y. X squared plus y squared, I should say. R sine theta is y. So now the 2 stays the same, so it's 2y. And then r cosine theta is x. So we're in our rectangular equation. If it doesn't specify what form the equation needs to be in, then you can certainly stop right here. If it says standard form, then you'll need to complete the square. So we'll go ahead and practice completing the square. When you complete the square, again, you want to get your x's together. So I'm going to move my x over. Go ahead and draw my blanks. Then I have my y squared. Then I draw my blanks, and I moved everything to the same side, so it's 0. So remember, in completing the square, you're trying to think of the number, the third number that would make these 3 terms become a perfect square. These 3. So you usually divide the 4 in half, which is 2. And 2 times 2 is 4. And the 4 has to go in both spots, because you're adding and subtracting the same number, keeping the equation equivalent. So same thing here. We've got our parentheses, y and y. It's going to be minus. We divide 2 in half and we get 1, so 1 goes here, and 1 is there as well. So I have x minus 2 squared minus 4. And then I have plus y minus 1 squared minus 1. Again, these factor and stay together. The subtraction terms are always on the outside. So then I can move both of my subtraction terms to the other side. So I have x minus 2 squared plus y minus 1 squared equals 5. And this would be my standard form answer. Again, if it doesn't specify standard form, you can stop right here. So you really just need to pay attention to the directions. A few more examples for us. This one's a pretty basic one. Convert r equals 5 into a rectangular equation. You might remember from a few lessons ago, r equals 5 is a circle. It's a circle with a radius of 5. So you might already remember what to do. But if you just start off with r equals 5, that's nothing. There's no sines or cosines. There's no r squared. So the only thing you can do is multiply both sides by r. Or sorry. You could try to multiply both sides by r. But then you kind of end up in this situation, which is even more complicated than what you were previously. Because now you have r squared and an r. But remember, you're always allowed, instead of multiplying everything by r, another way to get an r squared is to square both sides of the equation. So you have r squared equals 25, which is a true statement. Then you now know that r squared equals x squared plus y squared. And you get 25. So still a circle, just like all the other ones we did. But this time, the circle, we got the circle, we got the x squared plus y squared by squaring. And then the last one. This time we don't have any r's. We only have a theta, which is a little tricky because everything else we've dealt with thus far has had r's and sines and cosines and thetas in them. So if we go very back to the beginning, I told you this. Tangent of theta equals y over x, which you notice a lot when you see in a picture, but you don't necessarily think about it here. So whatever you do to one side of the equation, you have to do to the other. So what if we took the tangent of both sides? Oh. What if I said the tangent of theta is equal to the tangent of pi over 4? Still a true statement, because you're allowed to do the same thing to both sides of the equation. This time the tangent of theta is just going to say tangent. The tangent of pi over 4, or the tangent of 45, hopefully you remember that, is 1. So now you might think to yourself, well, why was this really even helpful? Now I have a tangent of theta, but remember, tangent of theta is y over x. So you can replace y over x equals 1. And then multiply to get rid of the fraction. So it's the equation y equals x. So that's another hint for you. When you only have a theta, and that's all I have for you about converting polar equations. Feel free to email me any questions, and as always, make good choices.